Okay, so my name is Nader Mahdi. I'm one of the SVT architect, and I'm here on behalf of the SVT Everyone team to talk about SVT Everyone and the latest results, as well as some little bit of roadmap of this quarter. Okay. What is SVT? So SVT stands for Scalable Video Technology, which is a standard agnostic architecture, a software architecture that is based on three main things, which is independently designed with emphasis on readability and easy of integration of any tools on top of it. Also, it's fully scalable and well optimized for the best possible trade-offs between performance, latency, and quality using a multi-dimensional parallelism, super block-based multi-stage partitioning decision, block-based multi-stage and multi-class mode decision, as well as rate distortion optimized classification and resource adaptive scalability. Yeah. So SVT uses many form and many technology of parallelism, such as picture-based parallelism, tile-based parallelism, as well as process-based parallelism, where splitting, which involves the splitting of the encoder operation into independent set of operation, namely analysis, mode decision, and encode and decode, and entropy encoder. Also, SVT uses the segment-based parallelism, which involves the splitting of the picture into many segments, and which allow to process multi segments in parallel. So SVT also use the multi-stage partitioning decision, where the complexity of where the complexity of each stage increases, going from the first stage to the next stage, while the number of partitioning to be tested is reduced in a big way. Similarly, the SVT uses multi-stage and multi-class mode decision, where each stage, the complexity of each stage reduced as you go from one to another, and the number of candidates, it's also reduced by a big factor from mode decision to another. So SVT also use an RD optimized classification, which consists of classifying the blocks inside each picture based on the spatial temporal classifier, and map each class to a certain number of features to minimize, to use as minimum as possible as minimum as possible of features which allows the best encoding time for while maintaining the best quality. So the multi-dimensional parallelism plus the multi-precision level feature, also the high optimization for Intel scalable Xeon and Intel Xeon D processor led or allow SVT to achieve multiple excellent trade-offs between performance, latency, and visual quality. Actually, we are able to build 13 encoder modes, and we are able to map those mode to a different kind of application, from going from vote to the high fast or to the real time application such as gaming. So going now to the SVT Everyone. The motivation behind SVT Everyone is to build a commercialized Everyone encoder, also that can be used as a platform for for future research and development, and that benefit from the easy understanding of the code and the full scalability provided by the architecture. Also, the competitive compression efficiency, as well as the integrated research decoder. So at NAB 2019, the SVT Everyone has been launched by Lincoln from Intel and David Ranka from Netflix, who yeah, so and David Ranka from Netflix. Also at IBC 2019, we were able to show the capability of SVT Everyone to be used as for vote kind of application by comparing it versus X264 very slow mode at 10 megabit per second for 1080p 60, and also the capability of using SVT for real time kind of application by having a full pipeline of where we use SVT Everyone live encoding from 1080p and 720p and 360p stack, and decoding on all web browser like Firefox, Chrome, Edge, and Safari using libdavid. So coming to the results. So here we try to compare the SVT Everyone 2-pass versus the libaom 2-pass in context of 100% CPU utilization, and I think we are here close to for the high quality modes. We are producing almost competitive coding efficiency. However, for the faster modes, so SVT Everyone it scale more and while preserving the better quality. Also, we did similar comparison in context of single instance, and using the SVT 1-pass as compared to libaom 2-pass. And as you see, so here, so the how the blue curve shows how SVT Everyone is scaling from mode to another. So what is more important to us is the incredible progress of the SVT Everyone going from since March 2019 until September 2019. Actually, we were able to achieve about 40% in coding efficiency in the high quality mode, which is pretty good. Pretty good progress, and it's also translates to the high speed modes. Also, we compared also the SVT Everyone mode 0 versus the X264, and we are about 60% better in coding efficiency. Similar, for real time, we compared also the SVT Everyone mode 6 as versus the X264 medium, and we are about 50% better in bit rate. So since September 2019, we also did good progress by improving the SVT Everyone and by adding the temporal by adding several features such as temporal filtering for 10 bits. Also, we add the ability to switch between 10-bit and 8-bit mode decision, as well as some standard features such as OBMC, palette, and global motion vector, which are almost done. I mean, we achieved the expected bit rate gain, but now they are in optimization phase. Also, we did some VMAF optimization. In terms of unit testing, also almost all of the encoder library function are covered now by unit testing, and from the decoder side, all features now are implemented, and we are testing the conformance, which is about 100% of David decoder test streams are passing, and those two, I mean, the unit testing and the decoder are two effort championed by Netflix. So for the rest of quarter 4, so we are planning to complete the development of the outstanding AV1 feature. Also, we are planning to continue the algorithmic optimization to achieve substantially improved speed bit rate trade-offs. And we're gonna also work on the documentation side, and we want to provide good documentation for all the encoder algorithm and workflow. We also gonna optimize the decoder and complete the unit test coverage, improve the open source management of SVT Everyone to allow more contributors to participate in the development process. Also, we're gonna continue the development of the public testing infrastructure to generate benchmarks to complete to complement the RB compressed state. So at the end, I wanna end my presentation by providing some useful link, so where you can find SVT Everyone, how you can contribute, how you can get more information about SVT Everyone. Yeah, and that's it. Thank you.
Thank you for sharing. There is a figure showing the difference between one-pass encoding and a two-pass encoding. Could you? Yes, this one. And it seems that the difference is less than 1%, but if my memory is correct, the benefit of two-pass encoding usually be larger than that number. So is there any particular reason?
Yeah, we just start on work on two-pass encoder, and yeah, we are sure we're gonna get better performance in the future. I mean, this is just scratching of the surface. Yeah.
Oh, okay, I see. Thank you.
Anybody else? Okay.
So if you have any question about the simulation or the configuration used, I have here backup slides that you can refer to.
It's cheating.
No, so they are available for everybody, so you can get them from Adrian.
Just a quick question.
Okay.
I saw that you mentioned you're using mode 6 for live. Can you say anything about the latency that's on the live encoding?
I think, if I'm not mistaken, I think it's about 4, right? 4, is it 4 and 5 seconds, yeah. Yeah, the good thing about SVT architecture is everything is configurable, so you can play with many trade-offs, even for latencies. Okay, thank you.
Thank you very much, Nader.